Hello there. Right, two people have asked about this question 15, so I'm going to go through the first part and the last part, some of which will apply to you, some of which will not. Like an idiot, I brought my visualizer away with me on holiday, but didn't bring the adapter to plug it into my laptop, so I'm using screen recorder with touch. So here we go. Um, Forgive me if this isn't awfully clear. Um, so to start with, hopefully you spotted that this was something that we need to use the quotient rule to differentiate. So I've put it in my windows. However, the bit here, which I need to differentiate down there, that itself I need to use the product rule to differentiate. So I've got a product rule within a quotient rule question here. So I used my product rule, got that as my answer, factorised it and plugged that in there. So I've 7x e to the x is my u, and I've differentiated that. Over here I've got my v, which is a bracket. So I multiply by the bracket, multiply by the power, reduce the power by 1, and then multiply by what I get when I differentiate the bracket, which is where this comes from. And a half times 3 is 3/2, so I've drawn it like that. Okay, so now remember the quotient rule is those two multiplied together minus those two multiplied together divided by v squared. Okay, so that gives us this rather horrible looking thing. And to get to that point, that's 4 marks, and that's a good effort. That's a good effort. So the remainder of the work, which there's quite a bit of it, as you're about to find out, is just to get that 1 extra mark. And it's a show me question, so we know what we're aiming for, but it's not nice. Okay, so the first thing I noted was that in the thing I've got to show it's the same as, this thing was to the power of 3/2, 1.5. At the moment, it's only to the power of 1. So I've multiplied by e to the 3x minus 2 to the power of a half, and I've got to multiply everything by that. But the good news is there are only 3 things. You've got this term here, which if I multiply by that, it just makes 3e to the x minus 2 to the power of 1. And then I've got, running out of colours, I've got this term here, and if I multiply that term by that, it just cancels out the minus a half. So when I've done that, I end up with this. So I'm sort of halfway to getting the denominator right, but the only other thing that's missing from the denominator is the 2. So I need to multiply, again, the 3 things by 2. So I need to multiply this by 2, which makes 2e to the 3x minus 2 to the power of 3/2, which is what I'm after. I need to multiply this by 2, which means the 3/2 just becomes 3. And you'll notice I'm not multiplying the 7 times the 3, but that's because of what the show me is. The show me the 7 is there on its own. Now the tricky bit is, how do you multiply this term by 2? I don't want to multiply the 7 by 2 to make 14 because there's a 7 in the answer. So what I chose to do was to multiply that bracket by 2, which is effectively multiplying the whole term by 2. So that becomes that. Okay, now can I rub some of that out? Oh, look at that, that's good. Okay, so what I've now got is the denominator right. My denominator here is correct. So I've just now got to sort out the numerator. So the first thing I did was I gridded that out, which gave me this. And getting close now, because I've got a minus 4 and a minus 4x, which is in the form that they want. So now here's perhaps the fiddly step, and that's unfortunately, it goes on a page break, but I've got Let's rub that out again, sorry. So I've got 7e to the x here and 7e to the x here. So I can bring a 7e to the x out here. So that's 7e to the x times all of that. There. And minus 7e to the x times that. So I've just put that term there in. So what I've done, going from here to here, it's the same numerator. And now if I look at the contents of the bracket, if I look at the contents of this bracket here, I've got my 2e to the 3x, I've got that, take away that, which gives me that, and the minus 4 and the minus 4x. And then, if I look at these two terms, I can factorise them to make that, which is what they want. Now, you know, that's a really convoluted process, and it was only because we were asked to write it in this form that I was able to get there, but it was really hard. But don't forget, that's one of the 5 marks for that question. An awful lot of work for that last one, and you know, the mark scheme makes it very clear that you get, yeah, if you get to this point here, get to that point there, that's colourful pen, you get 4 of those 5 marks. So you know, it's a tricky mark, but there we go. That's how you got it. I was asked about the final part. So the hang on, where's the final part? Here it is. Right. So the final part, you've got to show that, you know, this is the iteration equation, and you are asked to show that 3 decimal places it's that. This is an error interval question. So the error interval for 0.432 to 3 decimal places is everything from that to that. So what you do is, we normally do sign change before iteration, but here we're doing iteration after sign change. So what you need to do is take your iteration equation, rearrange it as an equals 0 equation, and then just try the 2 values from the error interval, and this has crashed, which is not good, and show that you get sign change. Show that one of those 2 values gives you a positive, and one of those 2 values gives you a negative. So that means the answer has to lie in between the 2. I'm sorry that that's crashed, but I'm hoping that that's clear to you. Please let me know if it's not. I hope this has worked.